see here. Okay. So this week's instructions, open Google Earth. As a group, go through the discussion questions listed below. As part of those questions, you will be directed to navigate to various locations in Google Earth. Record your answers on your downloaded copy of this document. So first one is fly to using the search bar this direction. This is the Hopkins Marine Lab. Hopkins. Zoom so that the eye altitude is close to 500 meters. Take a screenshot of this view and copy it here. Okay. It says to zoom so that the eye altitude is close to 500 meters. Oh. Boom, 500, sweet. And then we're supposed to take a picture. How do I do that? I think it's Control P. Control print screen. Okay. Control print screen. That's not. Oh, shoot. Save it. Paste it. Okay. Label all the coastal features you can see. Okay. Let's label these suckers.
We're labeling all the features we can see.
Yeah.
Okay, it's super small, so I can't see it very well, but
Just pulling up. I mean, there's definitely like a beach of some sort on the left. I'm just going to chapter what is this? Chapter 15, I think, in the terms to remember. Let's have most of them. There's beach, barrier island. What is that? That is not it.
looks like there might be cliffs, a bunch of rock.
It's rock. A headland. That's like the little, like the entire thing is a headland, I guess. Sea cliff, here you got that. I'll put C in front of it. Cliffs. Beach, sea cliffs, rock, headland. I don't really see a surf. There's like a marine, what is it called? Like the way the color changes. I think it's a marine terrace. And where it drops off, you can call that marine terrace, maybe. And okay. Yeah, that's good. Number 2, note the location of the top of the sea cliff. You may need to change the viewing angle and rotate your view to see where it is. Note the location of the top of the sea cliff. It may also be helpful to draw a path along the edge of the sea cliff. Turn on the historical imagery by clicking the little clock in the toolbar across the top of the screen. Then put the cursor towards the start of the timeline to display an image from September 7th, 1998. And compare the location of the sea cliff edge in 1998 to the most recent image. Has there been any sea cliff erosion at Hopkins Marine Lab since 1998? Okay, let's take a look. Okay. And there's a little clock. Oops. Okay, and it wants us to go from September 7th, 1998. Okay. September 7th, 1998. Let's do that. So that's what it looks like there. Play it. What? So, and I think for sure it looks like this area right here has been getting eroded slowly, just like kind of chopping away.
Yeah, I agree.
Let's see, so back up your answer with your observations. Cliff has been Okay. Now it wants us to fly to this place, 36.66. It's west. And then zoom so that the eye altitude is close to 500 meters. Take a screenshot, copy it here. Label in your screenshot where the surf zone is located. Okay, in the book, it says the surf zone is right here. So it says, as deep water approaches shore, it begins to feel the sea bottom and slow down. Circular water orbits flatten and the waves peak and breaks. The waves peak and then they break. In the foamy surf zone, water moves back and forth rather than in orbits. So like the surf zone is like, if I understand correctly, it's where the water, like when you're at the beach, how just like it sifts up and then it sifts back down. So it looks like it's right here where the dirt is wet and where all this white bubbles are.
Yeah, that's what it looks like to me.
Down. Oh, we need a screenshot. Shoot. Oops. Okay, so it says note the location of the top of the sea cliff in this location. It's the top of the sea cliff. You may need to change the viewing angle and rotate your view to see where it is. It may be helpful to draw a path along the edge of the sea cliff. Turn on historical imagery and compare the location of the sea from 1998 to the most recent times. Let's take a look at this one. 1998. Oh wait, it's like right on the ocean. Let's see what year it falls in. Oh, it's gone. Okay. Yeah, there used to be a building there. This thing totally got eroded. Location. Okay. Has there been much sea cliff erosion? There has been a ton of erosion where they're used to the building. It is now gone, and erosion has cut. It's probably cut like 10 meters inland, I'm guessing. Wow, 10, that's a lot. Get 5. No, probably 10 makes sense, yeah. Okay. Let's say. So now use the ruler tool to measure the distance, the edge of the sea cliff in 1998 to the edge of the sea cliff in the most recent image. Drawing the path along the edge of the sea cliff for both time periods is very helpful here. How far is the difference in meters? Oh, okay. That's what's asking. All right, so we want to go to September. The ruler. Line. Meters. Like right here. I mean, that's like the top. I don't know. Whoops. It's like 38 meters. And then in current times, $65 meters. $38 minus 65. What is that? 27. How many years has it been since 1998? It's been 24 years. So 24 divided by, oh wait, how many years has it been since? Oh, what is the rate in meters to years? So 27 divided by 24, 1.1 meters a year. Math's wrong, just let me know. And then, do you think it is good idea to build on either of this site or the Hop? Is a good idea to build on either of this site or the Hopkins Marine Lab? What do you guys think?
Um, can you go back to the picture?
Yeah. So there used to be a building here, but it fell into the ocean like 20 years ago. And then here, this one's not really eroding too much.
Yeah, probably that side, I'd say.
Thank you. All right, and then we're almost done. Next, we're gonna fly here and then zoom so that the eye altitude is about 800 meters. Take a screenshot and copy it here. Draw an arrow on your screenshot showing the dominant direction of the longshore drift. All right, so let's go. Okay, let me pull up longshore drift in the book real quick. Okay, so it says longshore drift is the movement of sediment parallel to the shore when waves strike the shoreline at an angle. So, let's see. Oh, 800 feet more or less. Okay. So yeah, it's like this sediment right here that's kind of parallel, I think. Let's take a screenshot. Oh. Let's see. Okay, and it's asking draw an arrow on your screenshot showing the dominant direction of the longshore drift. Small dominant direction. Looks like it's this way. And then, as a group, identify locations in Google Earth that show examples of the desert features listed below. You may not use any location or examples provided in the text or by your instructor. Take screenshots of each location. Label your screenshots with the important geological features found in each. So the first one's rain shadow. So rain shadow is a region having little rainfall because it is sheltered from prevailing rain-bearing winds by a range of hills. If you know of anywhere, just yell it out. Rain shadow. So we don't get rain because of the mountains. It's this place in Southern California.
There's a lot of the buttes in St. George.
On St. George.
Yeah.
Oh, a butte. Yeah. Okay. Let me grab one of those.
Is this me and you on here now?
Yeah.
The heck?
Let's see. Go. That's like a butte, right?
Yeah, I'd say so. Looks good to me.
Over here's a little bit better, I guess. Looks better in
What were the
person.
other options so I can start looking up some of the other ones?
Um, the other options are alluvial fan, or here, I'll text it in the Zoom chat.
Okay, cool. Do we have to take a screenshot of each one of these?
Yeah.
What the heck? Yeah, dude, I think any of those will work.
Huh?
I think any of those will work
Enya? Oh, any of the. Okay, gotcha.
for the view.
Label your screenshots of the important geological features featured in each one.
Are you serious?
Yeah. Okay, let's just get the photos first. I'm gonna grab my mouse. Let's be quicker. Just get the photos and then we can identify them after.
Okay, cool. It'd be helpful if we had a group.
I know. This is like an alluvial fan down here. Or I mean rain thing. This Sierra Nevada's up above. This desert down here.
Is that the rain one that you're looking up?
This is the rain shadow.
Okay.
All right, and then we need alluvial fan.
Alluvial fan, it shows that there's one in the Rocky Mountain National Park.
Rocky Mountain National Park. Is that in North Dakota? Or is that California? Or is that Utah or Colorado?
Colorado.
Okay. Okay. And then which part is it?
I don't know. When I looked it up, it just says alluvial fan, Rocky Mountain National Park.
Oh. Okay. Alluvial fan. Rocky Mountain National Park. Oh, alluvial fan trail. Let me pull it up. Go. I think it's this thing right here. It's like the sand that comes out of the canyon, right?
Yeah, it looks good to me. If it's wrong, she'll tell us.
Yeah.
And then
Barchan Dunes.
the dunes. It's just like a crescent shaped dune. So we just search up any sand dune, find a crescent shaped like arch from the wind.
Just like these, right? These little arches.
Yeah, yeah. Just screenshot that.
I think these are like super, or it's because we're so far out. That's why. Like zoom in super close.
And then the next one you can probably find on that same sand dunes. It's just like the little, little ripples in the sand dunes.
Yeah.
That's with the transverse dunes.
Transverse dunes. Those up. Zoom in super close. It's like tire tracks. Okay, and then parabolic dunes.
Give me just one sec. Parabolic dunes. If strong winds erode a section of the vegetated sand.
Oh, that's like over here on the East Coast. There's Leland, North Carolina. I think this is from wind. We'll use it. Okay, and then longitudinal dunes.
It's where there's like steps. Does that make sense?
Depths.
Like there's one layer that's low, and then there's like a step up, and then it's flat, and then there's steps up, and then it's flat again.
Oh, or
I don't know if you want to just look up a picture. It's not a very good example, but
longitudinal dunes. Longitudinal dunes. Images. Oh, I see. It's like the classic sand dunes.
yeah.
Those are like what, Egypt or something.
Mm, perfect.
Sweet. Okay. And then let's just identify these things real quick. So first one, the shadow. So label your screenshots with important geological features.
That is so overload. What are we supposed to say about it? It's exactly,
So
should we just copy and paste the definition?
I'll say it's hard to label on the picture. I'll say the mountain range of the High Sierras. Sierras is in the backdrop. The desert is down below. Mountains block rain from the desert. Okay, cool. And then a butte. What do I want to say about this one? Fluvial fan, that's just where the